All right, let's do this. Recursive rules for quadratic patterns, the official tutorial. So we're going to start with pattern 1. You can copy it down. Oops, that's not supposed to be there. You can copy it down or you can just follow along. So if you look at the pattern, all the x's are going up by 1, but the y's is doing something funny. So the y first goes down by -6. So the first change is -6. Then the second time, let's just change this font real quick. All size 24. So then the second time we go from 8 to 4, -4. Then we go 4 to 2, -2. So we are not changing by the same number every time. This is not linear. We can look and see, is it multiplying by the same number every time? No. From 8 to 4, it looks like we have a pattern 1/2, 4 to 2, 1/2. But then 2 to 2, that's just times 1. So let's just continue our change and see if we can figure out another pattern. So this one was -4. From here to here was -2. From here to here it's -0. Hopefully you're starting to see what I'm seeing. Every single time the change is changing by 2. So the second difference would be +2, +2, +2. So we can already predict that the next change is going to be +2 because all the numbers are 2 apart. So the change is not a constant. It's not a constant rate of change. It's a linear rate of change. That allows us to set up our recursive structure. So we always have f of n plus 1. My next one is what I have now plus the change in y. Since the change in y isn't a single number, we actually have to figure out what is the rule for the change. So the rule for the change, or the pattern for the change, I won't put the pattern. Pattern for the change, we know that's going up by 2 every time, so that's 2 times n. Okay, we're just going to switch out n for x. Okay, so every time we're going to be adding 2, our slope is 2, and then our y-intercept right here is at the 0 point. So 2n minus 2 seems to be the pattern. Let's test it out. Right here, this is our value. 2 times -2 is -4. -4 minus 2 is -6. We changed -6, 14 to 8. That's true. Let's jump down here. At 1, 2 times 1 is 2. 2 minus 2 is 0. So at 1, we did not change at all. It's a 0 change. So the pattern seems to be holding. So using what we did over here, after the second x value, or excuse me, x value number 2, we need to add another 2. So that means this one would be 4. So there really is a method to the madness. So here goes the full rule. Our rule for pattern 1 is f of n plus 1 equals f of n, and then you're going to replace the whole thing with 2n minus 2. That's our change in y. Has a nice linear pattern. And then for f of 0, our starting value, you want to swing yourself back to the original. So our original and 4. So there goes our full rule. Start at 0. Okay. So at 0 I have 4, and then at 2n minus 2. 2n minus 2 is minus 2, 2. Add 0, 2. Add 2, I'm at 4. The next one's going to say add 4, I'm at 8. Then it's going to say add 6, I'm at 14. Add 8, I'm at 22. You can figure out the rest of the pattern. So that is pattern number 1. Woo, woo.